Okay, so this is section 10.1, solving quadratic equations using the square root method. We've already talked about solving quadratic equations by factoring and then using or applying the zero product property. And so now we're adding another method kind of to our toolbox for solving quadratic equations. So you right now know two methods for solving an equation like this, x squared equals to 4. There's by inspection. Let me switch colors. So by inspection, where you just look at the equation x squared equals to 4 and you go, okay, well, what values, what real numbers could x be that would make this a true statement, that would make the left-hand side equal to the right-hand side? And you would say x is equal to -2 or x is equal to +2. Both of those would work. And then you guys also know how to solve a quadratic equation like this by factoring. Where to solve an equation by factoring, we need to have 0 on one side of the equation. So if we were to subtract 4 from each side of the equation here, we would end up with x squared minus 4 equals to 0. That's a difference of 2 squares, so it factors to x minus 2 times x plus 2 equals to 0. And then by the zero product property, x minus 2 equals to 0, or x plus 2 equals to 0. So x equals to +2 or x equals to -2. And we can also use set notation to represent those solutions. Or this can also be written as x is equal to ±2. So now we're going to look at solving quadratic equations using the square root method. Now you can't solve every quadratic equation by factoring, and you can't solve every quadratic equation by square root method, but whenever you can, these are often more efficient methods to use. So basically, if we have an equation of the form x squared equals to c, where c is a positive number, then x will be equal to the square root of c, or x will equal to the negative square root of c, which we said can also be written as x equals to plus or minus the square root of c. And we saw that in the last example. So when we had x squared equals to +4, notice that x squared is by itself on one side of the equation, and then we have the positive constant 4 on the right-hand side of the equation. So x is equal to plus or minus the square root of 4, and we know that the square root of 4 is 2, so we end up with x is equal to plus or minus 2. That represents two solutions, x equals to +2 or x equals to -2. Okay. So here we want x squared to be by itself on one side of the equation. So we could add 16 to each side of the equation to have x squared equals to +16. And then when we take the square root of each side, we'll get x is equal to plus or minus the square root of 16. And the square root of 16 is +4. So x equals to -4 or x equals to +4. Now I said that both of these are representations of your solution set. For now, I would like you guys to also separate the answer just to emphasize that represents two solutions. If you don't have that plus or minus, you're missing half of your solution. So it's super important that you have the plus or minus. Okay, so if we try and isolate the perfect square here, we would end up with x squared equals to -16. And something should be kind of going off in your head that, oh, this isn't going to work, because you have to think, is there any real number that when squared So multiply by itself will give you a negative number, and the answer is no. And you'll see if we attempt to use square root method here, we would get x is equal to plus or minus the square root of negative 16. Okay, this is actually an imaginary number. When we were talking about simplifying radicals, we talked about this. This would actually end up simplifying to plus or minus 4i, okay, but this is an imaginary, these are imaginary solutions to the equation. Okay, and imaginary numbers are not real numbers. So for in Algebra 1, we're just going to say that there are no real solutions here. Okay, imaginary numbers are actually part of the complex number system, which the real numbers are a subset of, but the imaginary numbers are not a subset of the real number system. Okay, so we're set up here. I'll just stay in green. So we'll get x is equal to plus or minus the square root of 121. So we get x equals to plus or minus 11, and I would like you guys for now to separate the solutions just to emphasize that there's two solutions. There's two real numbers that would make this a true statement. Okay, I'm going to skip the you tries. Okay, so this is just kind of a step up in difficulty or complexity. We need to first isolate the x squared. So we're going to divide by 25. So we'll get x squared equals to 4 25ths. X equals to plus or minus, so when we take the square root of each side, we get x equals to plus or minus 4 over 25. And remember that when we take the square root of a over b, that's equal to the square root of a over the square root of b. Well, in this case, both our numerator and our denominator are perfect squares. So we actually just end up with plus or minus 2/5. So x is equal to negative 2/5, or x is equal to positive 2/5. Okay, need to isolate the x squared, so we divide by 4. When we go to take the square root of each side, we get x equals to plus or minus the square root of 9/4. And like the last example, the numerator and denominator here, so 9 is a perfect square and 4 is a perfect square. So we get plus or minus 3/2. So x equals to negative 3/2, or x equals to positive 3/2. We're going to skip the you try. Okay, let's switch colors again. We'll go dark blue. Okay, so x squared is by itself on the left-hand side of the equation. So if we take the square root of each side, we'll get x equals to plus or minus the square root of 45. And we think to ourselves, okay, well, does 45 have any perfect square factors? And it does, and I'm going to write out this extra step here, but you guys can maybe just go directly to simplifying the square root of 45. But I know that 9 times 5 is 45. And 9 is a perfect square. 5 is a prime number, so we're going to actually end up with x equals to plus or minus 3√5. So when we separate, x equals to negative 3√5. Or x equals to positive 3√5. Okay, x squared is by itself. So we take the square root of each side, we get x equals to plus or minus root 32. Does 32 have any perfect square factors? It has multiple perfect square factors, but what's the largest one? Well, half of 32 is 16. So this will end up being 6 times 2 is 32. So we'll have plus or minus 4 root 2. So x equals to negative 4 root 2, or x equals to positive 4 root 2. Okay, so this is where the lesson starts on Friday. Notice that we now have a binomial squared here. Okay, so basically, whatever's inside the parentheses here being squared, when that quantity is squared, it needs to be equal to 9. So we're going to follow the same steps, except for when we take the square root of each side, we're going to still have x minus 1 on the left-hand side, and then we'll have plus or minus the square root of 9, which you could probably have skipped writing this step because you guys know that the square root of 9 is is 3, so we'll have plus or minus 3. Now this is the important next step. We need to finish isolating x. So we're going to add 1 to each side of the equation, and I'm going to put the 1 in front of the plus or minus 3. So one of our solutions will be 1 plus 3, and the other solution will be 1 minus 3. Well, 1 plus 3 is 4, and 1 minus 3 is minus 2, or negative 2. And we could think about if we were to check by substituting back in. When we check x equals to 4, we would have 4 minus 1 squared equals to 9. Well, that's just 3 squared. So 9 equals to 9. That works. Okay. And then for negative 2, right? Negative 2 minus 1 would be negative 3. And negative 3 squared is 9. So it also works. Okay. So we want to get to the x plus 2 because the x plus 2 is being squared. So we take the square root of each side. We'll get x plus 2 equals to plus or minus the square root of 49, which is 7. To finish isolating x, we're going to subtract 2 from each side of the equation. So I'm going to put the minus 2 in front of the plus or minus 7. So x equals to negative 2 plus 7, or x equals to negative 2 minus 7. So x equals to negative 5, or x equals to negative 9. Okay, we have an extra step here because we want to get the perfect square isolated here. So we're going to add 40 to each side so that we can then use square root method. And x minus 4 equals to plus or minus the square root of 40. Okay, 40 is not a perfect square, but it does have a perfect square factor. I believe that 4 is the largest perfect square factor of 40. So we'll have plus or minus 2 root 10, right? Because 40, square root of 40 is equal to the square root of 4 times 10. That would be root 4 times root 10, so 2 root 10. Okay, and then adding 4 to each side of the equation, we'll have 4 plus or minus root 10. So x equals to 4 plus 2 root 10, or x equals to 4 minus 2 root 10. Remember, we can only add radicals when we have like a common radical factor in them, where we could think about combining like terms. So we're actually just going to leave our solutions as 4 plus 2 root 10. and 4 minus 2 root 10. Those are the exact values for x. If we wanted to get a decimal approximation, you could pop that into your calculator, and you would end up having to round your answer to whatever decimal place was asked for. But we prefer the exact values. Okay? So, 2x plus 1 equals 2 plus or minus the square root of 48. I believe 16 goes into 48 3 times, so we'll have 2x plus 1 equals 2 plus or minus 4 root 3. And then we want to finish isolating x, so we need to subtract 1 from each side of the equation. And divide by 2. So when we separate our solutions, we'll have x is equal to negative 1 plus 4 root 3 over 2, or x is equal to negative 1 minus 4 root 3 over 2. And if you wanted to split up into 2 fractions, that's also okay. I'm okay with you guys leaving your answer here. Okay. But you always could rewrite this as negative 1/2. That will become 4 root 3 over 2 would become 2 root 3. And then we also have negative 1/2 minus, that would be minus 2 root 3. Okay. Both represent, both just different ways to write those solutions. Okay, so we take the square root of each side. We'll get x minus 5 equals 2 plus or minus the square root of 4/9, which the square root of 4/9 is going to be 2 plus or minus 2/3. We add 5 to each side of the equation. So we get x equals to 5 plus 2/3. Or x equals to 5 minus 2/3. If we want to get a common denominator of 3, we'll end up with 15/3 plus 2/3, which is 17/3. Okay, so 15/3 minus 2/3 equals to 13/3. Okay, so here 17/3 and 13/3 are our solutions. Okay, we want to isolate x minus 2 squared. So we're going to first add 1 to each side of the equation. Then divide by 16 on each side. Okay, now we're ready to take the square root of each side of the equation. So we'll have x minus 2 equals 2 plus or minus the square root of 1 over 16. Now remember, 1 is a perfect square. The square root of 1 is 1. So we'll have x minus 2 equals 2 plus or minus 1/4, and 16 is also a perfect square. And then when we add 2 to each side of the equation, we'll have x equals to 2 plus 1/4, or x equals to 2 minus 1/4. Okay, getting a common denominator, that's going to be 8/4 plus 1/4, which is 9/4. Or 8/4 minus 1/4, which is 7/4. Okay, so our solutions for this equation are 9/4 or 7/4. So this is solving quadratic equations with square root method.